Thank you very much for being here. And I put a subtitle to my presentation, which is the other side of peak oil, which is waste. Waste is the other side of mineral extraction. So we take things from the earth, use them in the industrial systems, and then we throw them away. That's what we call growth, economic growth. And so the other side of picking is picking on the other side, peak waste. There is something like that. But I start telling you something about the problem, and we sketch something about the solution. This is just an illustration of the problem. It's a diamond mine somewhere in Russia. It's all what is left is a big hole in the ground. And this is a problem, not so much this one, because this specific hole is a problem maybe only if you walk at night and drunken and so that you could fall in. But the big problem of these things is they being depleted. We have been making a lot of holes in the ground, and extraction is becoming more and more difficult. Then, on the other side, you are the opposite. All that stuff that was inside the hole must be somewhere, and it is mainly still in landfills, what we call landfills, which are hills. Now, you could match the landfill and the hole and get it even. So in a certain way, you would solve at least the aesthetic problem. The problem is that if you fill a hole, a mine, an old mine, with the material that you find in a landfill, you don't get back the mine. You even out, but it's not anymore a mine. This material here that you see, it's a mix of everything we have been using in our industrial system. It is not a mine. It's very difficult to extract anything out of this. There is an idea which is around, you may have heard of it, it's landfill mining. You heard of it, but it is not at all easy, because a landfill has never been thought as a mine. It is not a mine. It's extremely difficult to mine. It has never really been done. There have been some studies, but it's extremely difficult. So the problem is that we are running out of mines and getting full of landfills, which is not exactly what we want. We would still have mines. We would like to have mines. We don't like to have landfills, and that's the problem, because we are going through our civilization cycle by making more and more efforts to mine out of a less and less concentrated deposits. This is what I call the universal mining machine paradigm, which is not, this is just an illustration. This is a real machine which exists in Germany. But all mining consists today in taking rock from the ground, you crush the rock, you send it somewhere, you process it, you take out the useful minerals, and the rest is called tailings, which is another form of landfill. Now, the problem is that in order for this kind of machines to work, you need to have a certain concentration of mineral in your ore. The thing you need to use, you want to use, needs to be a typical around 1%, a little less, a little more, but this is the kind of concentration we speak about when talking about mines. As we run out of high concentration deposits, we still need to do this on a larger and larger scale, and we are running against a wall, essentially, because you can make calculations, and you cannot do it if you were to extract minerals from the ground, undifferentiated ground. You could not do it because it would be too expensive. You can make calculations even in optimistic consideration. You're talking of using amounts of energy which are orders of magnitude larger than what we are producing now. So we can mine things today because we are using for free energy which has been accumulated over millions of years. millions, or maybe even billions in some cases. So that's our main problem, the problem of our civilization, because our civilization is based on minerals, and if we don't have minerals, it is a big, big problem. And just to remind you, the story of the limits to growth, we have been discussing that, and there has been an intervention yesterday by Dennis Meadows, one of the authors. You remember that scenarios predict collapse, if you like to call it, but is a decline, essentially, which is due to essentially to this problem. There is nothing, in these scenarios, we don't run out of anything. Minerals do not disappear, but they become more and more expensive to extract. As they become more expensive, then you need to more and more capital for extraction. Eventually, you are left without capital for all those nice things that we would like to do to our cities, like rebuild them and to make them nicer, and to make things like public transportation. So we have a problem. It's a big problem. It's the problem, the civilization survival problem. And how could we possibly solve it? There is only one way. We cannot solve it by brute force, unless we have some miracle. But I mean, when I make a business plan, I also make a version with a miracle, but it's not usually very well accepted. So if we want to make a business plan for this civilization, we cannot hope in miracles, and there's only one way. It is to close the industrial cycle, like if it were a biosystem, an ecosystem has no waste overall. So you recycle everything. The ecosystem has been around probably for 4 billion years. We never run out of anything. But in this case, our system is so poorly designed that we will run out of the main things we need in a few decades. So how do we do that? There is a lot of discussion on this point. I'm just using this as an illustration again, because the concept expressed by Braungart and McDonough, they have this nice sentence: waste equal food is equal to food, which is a very nice way of saying, in a very synthetic way. You can use this term to get a grasp of what you have to do, because this is the way ecosystems work. Our industrial system, unfortunately, does not work this way, because if waste is food, then you don't burn your food normally. You don't incinerate your food because it smells bad. Well, one may want to do that, but you don't throw your food into a hole and then you cover it with earth until you don't see it anymore. So once you start thinking in these terms, then you think that ways to proceed to make the cycle of the industrial system, to reform, to change it in such a way to be able to close it. See, the problem we have is not only of energy. I venture to say that energy is a minor problem, because we can solve it. There are solutions. But the minerals, it's a very big and difficult problem. We can use solar energy, as we heard today, instead of oil, or you can use different forms of oil. But minerals, you need copper. You don't get copper from the sun. It is not blown by the wind. So you have to close the industrial cycle. I'll give you a few examples, things that we try to do, and this is one example. I think is interesting. This you may recognize is a Fiat 500. It's not mine, just a picture taken somewhere. And this is waste, of course. Then the conventional wisdom of this kind of things is that you recycle it, which is fine. Most old cars are crushed into a cube, and the cube is taken into a blast furnace. And then you get steel back, which is unfortunately not very efficient. It's very inefficient, and there is a big problem called downcycling. Have you ever heard of downcycling? Which means this car, even this old car, maybe 30 years old, contains a lot of materials which are not iron. Contains chromium, zinc, copper, aluminum, probably others. And so what you get, the steel that you get out of this car has a memory of what it was before. And this may not be the steel you want. So it is a very inefficient way of recycling this car. So we tried a different way of doing it. A few years ago, we tried a project. Instead of crushing the car, having it go through a blast furnace, then casting it again in the form of a car, we repainted it and retrofitted into an electric car powered by lithium batteries. And what we got was a very nice microcar, which cost about half than what you could buy on the market from China or from Korea, which has several advantages. It doesn't come necessarily with this lady. Actually, she's not retrofitted. That's something that unfortunately we cannot do it with human beings. With car, you can rejuvenate the car. Humans, still a little bit difficult, but apart from that, it has a lot of advantage, and not showing you this as an example, but the people who do the LCA calculation, they agree with us that it's enormously more efficient to reuse an old car, transform it like that, than destroy it and build a new one, make a new one. And so this was an interesting experiment also for the way it was taken. Because, we didn't know we were so subversive in doing this. It's very subversive to do. You're reusing an old car. Come on, this is not the right. You got to destroy things if you want to be a good member of society. It's consumption, It's you want to grow, you must scrap things and make new ones. So this is what was interesting. I think that the city of Florence, it's my suspicion, made a law expressly to forbid this kind of cars to run. It's I'm a bit conspiracy theory, but I think there's got to be a reason for some things. But that one example. Another example that I think might be interesting for you. We have been studying this. This is a painting, 19th century, about gleaning. Now, excuse me if I make a little poll with you. I exploit your presence. How many of you know what is gleaning? Please raise your hand.
What is what?
Gleaning. Gleaning. You do. Fantastic. Well, a few people know. It's a miracle. Thank you. You know what is gleaning. And for the vast majority who don't know that, let me tell you that it's part of the agricultural process. Harvesting is a process which has a maximum efficiency in a certain fraction of the grains recovered. As all process, industrial or biological process, it has a maximum because after that you start having losses. Because if you want for a harvester who goes with a scythe, right? It's pronounced it right, and he cannot recover every single grain. There is an optimal rate of loss. Maximum gain of the process. Then the process is optimized by the second kind of process, which is made by people who collect the grains fallen on the ground. It's a very ancient process. It's very, very efficient. And it's been in place up until maybe 100 years ago. It is still legal in France. In Russia, at the time of Stalin, you would be shot if you try to do that. For some reason, and I don't know about Italy, maybe they shot you anyway, but for some reason. Anyway, the question that I was asking myself before going into this is whether there is such a thing as an urban gleaning. Can you do this in cities? Because city, as we saw in the previous presentation, is a highly structured, beautiful, wonderful system of exchanging goods and services. But in terms of waste collection and management, it's very poor normally, despite lots of progress made recently. But it is very primitive in comparison with the way all the services in a city are structured, which is very fancy. Now the answer may be yes. Maybe there is such a thing. It's being developed now. It takes a different name. It takes this strange name, Participatory Sustainable Waste Management. The lady you see here is Professor Gutberlet, who is teaches at the University of Alberta in Canada. And this guy is a sort of gleaner, a catador, it's called. And he's not alone. It's an association of catadores. They collect waste. They recycle what they can recycle. If they find something that still works, they use it. And the interesting point of this work is that this idea of the catadores, the collectors, is growing up, and it took some political meaning in the sense that, for instance, President Lula met with the Brazilian catadores a few years ago. And because it is a concept which is completely different than the vertical way waste collection is normally organized in towns. It's something that goes up from the bottom. It's an idea of people who get together, they organize, and then they collect waste for money. You don't get rich, actually, I'm sure. But it's something that seems to work. It is so interesting that I decided to try something like that. Not myself to become a catador, but you see, this is a picture taken a few years ago, and it's very close to my university. These ladies are part of the, call it village, the community of the Roma, which of course means gypsies, essentially, and they have been doing recycling of steel and iron, scrap iron. And this is also a very interesting idea. We made a project, it's very interesting. I mean, I could tell you several stories about that. I just tell you that once you start doing these kind of things, your vision of the world changes quite a bit. But what I want to say, essentially, this kind of process is extremely efficient because you do it without the mass of bureaucracy, which is typical of waste collection, the way it is organized now. So I think it's the only possible way that the system can adapt to a situation in which you have to adapt all stages of production and disposal in such a way to optimize collection and reuse first, the most important, and then recycling when reuse is not possible. And it's an extremely complex system which cannot be legislated from above. But just for this reason, it's almost impossible to do it now because legislation, bureaucracy is fantastic. I know the case of Italy, and but I don't know exactly how it is in other countries, but it turned out to be extremely difficult. Just to tell you the story, these people here, they were encouraged by the government to set up this activity. And then the government changed their mind. Another section of the government is schizophrenic, and so they sent the police with the machine guns to arrest them because it turned out after a while that it was illegal for some reason. I escaped. No, I wasn't there when they arrested the Roma for doing that. But it's interesting. So let me. I just don't have much time to tell you the details, but I hope I gave you enough ideas that we can discuss about that later. I would like to thank the people who have been helping me in these ideas. We have been doing this work, and just notice that these young Roma children, they're perceived often as a problem. But I think, considering that we are facing the most important problem in our civilization, that of closing the industrial circle, the industrial cycle, then we have to see these children not as problems, but as solutions, as resources. We probably need them as much as probably more than they need us. Thank you very much.
Thank you, Ugo, very much from not only peak oil, but peak everything perspective, and have a look at the sustainable use of resources. Are there any questions on Ugo's presentation? Yes, please.
Ugo, are you familiar with the work of Gunther Pauli?
I'm sorry, you catch me unprepared. You should tell me.
I mean, he does a lot of work with UNIDO, but he was one of the founders of Ecover, the Belgian company that makes green household products. And he's moved on from there now, and he designs cyclical industrial systems. But you know, he's done it. He's on a fairly large scale. So using that principle that waste is food. And, you know, he'd be a very interesting person to talk to if you want to take
Thank you.
your work.
Thank you. See, there's a vast field. It's being moved the idea of making this C2C, cradle to cradle idea. However, on the average, the number of products which are designed according to this philosophy is still very, very small. Some people are enlightened enough that they do it.
So thank you. There's Michael Clare having another question.
This is very, very interesting. Applaud your work. I want to know if you know anything about recycling and the rare minerals in these things and in laptops, because every one of these is made with conflict minerals. Coltan.
Yes, this is a big problem, and needs.
So on. But people throw these away in laptops and all of that, and they all contain these rare minerals. So is it possible to
You probably know more than me on this point, but it's a subfield of waste management science. I have not specifically worked on this field, but I know from people who work how it is done. It is typically European electronic scrap is sent to China, and there it's recovered by very poor and primitive means. Typically, they burn it to recover the gold. The rest is not recovered. For instance, the precious indium, which is inside these things, it's lost, and it's a very big problem which cannot be solved from the side of the waste management. You need to design objects in such a way that are easy to recycle. Otherwise, it's a disaster.
Thank you. There is.
That's why I use much simpler things.
One final question in the front here. Yeah.
Good afternoon. As energy becomes more expensive and the products that we get from energy become more expensive, do you think that those that have the products will stop throwing them away? There will be less waste as a consequence compared to history?
Yes, it's a problem of optimization of the system. The system is, some people say that we should aim at zero waste, which could be a good idea if you consider this as the whole cycle. The whole cycle must have zero waste. But every single process within the cycle is optimized in a condition that may produce or should produce some waste. This waste is picked up by other cycles within the main cycle, and then the combination of all these smaller cycles produce zero waste. But personally, I'd say that it's not a good aim that of zero waste for every single production cycle. But your question was probably different now that I'm rethinking about that. But you're right. We notice, working in this field, that the garbage contains less and less precious minerals like copper, metal, zinc, and things. So that makes things difficult for recyclers, makes more expensive. That's one of the reasons why landfill mining turns out not to be a viable concept, because at the beginning people made some estimation there's so much metals in these landfills that we can mine them. Then as you grow, there's less and less and less.
I very much appreciate the approach and angle you're taking about from a bottom-up and sort of community survival and income. Working in government, certainly in the UK, the waste stream is increasingly tied up in large contracts with long-term capital expenditure, and I suspect that within a few years there will not be the tonnage to go through those large plants, incineration or whatever, and so there'll be a lot of embarrassment. I think.
Absolutely right. Absolutely.
So
right.
Thank
That's
you.
what's going to happen.
Yeah. Thank you, Ugo. Yeah.